In this video, we are going to look at how to apply our concepts of solving systems of equations to systems that are made up of linear and nonlinear graphs. And nonlinear means we're going to be dealing with graphs that are curved. We have polynomials, we have quadratics, there could also be circles, just anything with a curve on it. So we're going to see, for the most part, squared terms like x squared and maybe even a y squared every once in a while, and that's going to tell us we're dealing with a curved graph. So in the first part, we're just going to look at the different types of solutions we're going to have when dealing with these type of systems. And the one that's probably going to occur the most is two solutions. Is if I draw a line from one of the graphs, so there's one graph, and I draw a quadratic for another graph. We can see 2 points of intersection. So this is going to have two solutions. Now, for the most part, if we're dealing with quadratics and lines, there's only going to be a lot of times two solutions based off of how the graph looks. No matter where I draw the line, for many, many cases, there are going to be two solutions. Now, there is a way to draw a linear and a quadratic with one solution. Now, the most basic is if I draw a quadratic, and don't copy this one down because it's the most basic, doesn't occur very often, is then I have a horizontal line right at the vertex. And then we have one solution. Now, most of the ones that have one solution are going to be something called tangent, which means next to the graph. So I have a quadratic, and I can have a linear, but what I'm going to do is I'm going to mark that intersection first with the linear, and then I'm going to draw it from there. So I want it to intersect just at that one spot. And so it's going to be a line that just touches at that one spot and keeps going. In this case, we do have only 1 point of intersection. And in math, we call this a tangent. It touches the graph at one spot, and that's it. You can also have no solutions. Again, the most basic, don't copy down the linear graph, because the most basic is just to have a parabola and then just to throw a horizontal line down below it. You notice there will be no intersections. But the line doesn't have to be horizontal. It can have a slope to it. And so I see right here the parabola is opening up, and it's still not going to touch my linear. And so this is an example of no solutions. So if we look at this, one solution, no solutions, that for the most part is what we dealt with. We had infinite solutions for linears. But now, since we have a line and a parabola, we're going to be dealing with two solutions. The way we're going to be dealing with this stuff first for solving is we are going to use the substitution method. It'll be the easiest method to deal with. And the other thing we're going to focus on is we are going to have to factor. Factoring is going to play a big role with solving because we're dealing with a quadratic. And so when you're dealing with a quadratic, we always factor to solve. So that tells me it's going to play a big role in our solving process. And since we're looking for points of intersection, we're going to have to plug in all our solutions to find the y values. So organization is a very, very big deal. So in the first case, if I look at this example, x squared plus 4x minus y equals 7, 2x1 equals y. I notice it's set up directly for substitution. I can plug one directly in the other. So I'm going to do that. I have x squared plus 4x, I'm going to do minus a parentheses. And in that side, that parentheses, I'm going to plug in my 2x plus 1. And that equals 7. To help us with distributing, make sure you input, we have a minus sign, so I want it to be a -1 right there. That will help me when I'm distributing to make sure I don't make any small calculation mistakes. So I have x squared plus 4x, going to distribute and I'm going to combine my like terms. So x squared plus 2x minus 1 equals 7. So same idea. When you distribute, you're going to combine like terms afterwards, you're going to substitute in. So really, structurally, it's the same concept. We're just dealing with more squareds. The next part of the direction is saying, now after we do this, after we use substitution, we're going to want to set it equal to 0. That's going to allow us to factor. So I want this to be 0, so I'm going to subtract 7 from both sides. So I have x squared plus 2x minus 8 equals 0. It's been a while since we factored, so let's go through the whole process again. We have our box. The x squared goes on top. The negative 8 goes on the bottom right. And over to the side, we're going to go ahead and just make our little diamond, our x. And on the top, it's what multiplies. So we know that this diagonal is going to multiply to negative 8. It has the same product of this diagonal. We also know this diagonal is going to add to this middle term. These two terms combined give you this one. So they're going to add to 2. So I need to figure out what numbers multiply to negative 8, but they add to 2, and I'm going to say that's a 4 and a negative 2. If I take a look, it does appear to work. 4 times negative 2 is negative 8. 4 plus negative 2 is 2. So I'm going to put a 4x here, and I'm putting a negative 2x here. Now we have the whole inside, so we're going to label the dimensions. To create the x squared, we have an x and an x. To create this negative 2x, the x needs to be multiplied by, it looks like, a negative 2. And then I can see x times what gives me 4x, and that would be 4. And we can always check, do I get negative 8 by multiplying the last digits, negative 2 and 4, do give me negative 8. So I completely factored. So I have x plus 4 times x minus 2 equals 0. That, I'm going to be honest, is probably the hardest part that you're going to be dealing with, that left side. Distributing, combine like terms, set equal to 0, and factoring. Once you get to this blue part, it's actually very easy to do. Is we just solve like we did before. If x plus 4 equals 0, x equals negative 4. If x minus 2 equals 0, x equals 2. So I notice I'm going to have, it looks like, 2 solutions. And these are points of intersection. So I know I have an x coordinate of negative 4, and I have another x coordinate of 2. I don't know the y values associated with them. So I take these and I plug them in to the formula we had before, this y equals 2x plus 1. So I have y equals 2x plus 1, and I'm going to plug in my x values. So y equals 2 times negative 4 plus 1, which is negative 8 plus 1. So y equals negative 7. And so negative 4, when I plug that in, again, output a negative 7, so that gives me the first coordinate, the first solution they intersect at. Now I'm going to plug in my 2. And if I plug in that 2, y equals 2 times 2 plus 1, which is 4 plus 1, so I get y equals 5. And so the 2 input gave an output of 5, so that creates the other coordinate. So there's our 2 solutions. Once we get to this right side, once we get to this blue part right here, we know that it's the same idea as before. You plug in your x, you get your y, write it as a coordinate. It's just we see we have 2 x's. So we're going to have to plug them both in and get the output for each one. Organization is really important in this lesson. And notice how I try to organize it. As I try to do my solving on the left-hand side, as soon as I factored, went over to the right, got my coordinates. I try to keep my x of negative 4 to the left, my x equals 2 to the right, so I did not accidentally put the wrong y value with the wrong x value. This is going to be kind of our setup for, say, majority of the problems. So let's look at this one. X squared minus y equals 0, 2x plus y equals 0. I'm still going to use substitution for this because the directions say so. And so what I'm going to do is I'm going to take this top equation and I am going to solve for y. Or I can take this bottom equation and I can solve for y. Now, if I look at the two for substitution, I believe it's going to be easier to solve for y here because we have a positive y. So I'm going to take that equation, and to solve for y, I am going to subtract 2x. That's going to isolate the y term. So I have y equals, well, 0 minus 2x is just a negative 2x. I'm going to take this and plug it in for y in the other equation. That's what substitution is. I just, in this case, had to solve, so it was a little more complicated at the beginning. So x squared minus y equals 0, but instead of y, I'm going to plug in my negative 2x. And then I distribute x squared, negative is positive, plus 2x. In this case, I would look at, can I combine like terms? There are no like terms. I need to now set equal to 0. Oh, look at that, it's already equal to 0. So this, remember, is a different factoring technique because unlike the previous example where we had a trinomial, we had 3 terms. In this case, we have 2 terms. And so for factoring this, it's the idea of GCF. I only have 2 terms. I don't have a constant, so I'm going to put just one row, x squared and a 2x. They have an x in common. I can factor that out. I get GCF, and then I can fill in the top. X times what gives me x squared? Looks like x. X times what gives me 2x? And it's 2. So the factors here are x and x plus 2. And quickly check, by the way, especially when you do GCF, it's very easy. X times x is x squared. X times 2 is 2x. So those are my factors. I'm going to set each one equal to 0. So set x equal to 0 and solve. There's no solving needed. Set x plus 2 equal to 0. X equals negative 2. So again, I have 2 x values. I am going to plug them in and find the y value that's associated. Well, y equals negative 2x is what we found. So if I plug in 0 for x for my input, I get y equals negative 2 times 0, which is just y equals 0. So when I have an input of 0, I have an output of 0. So that's the first solution. 0, 0, an x of 0, a y of 0. And then input the negative 2 for x. So y equals negative 2 times negative 2, y equals 4. So I have the coordinate negative 2, 4. Negative 2 is my input for x, 4 was the output for y. And so there is the other solution. So again, notice we have 2 solutions for this. And the process didn't change. And this organization is extremely important, especially with all the distributing and combining terms that we did in the first example, is you're more likely to make a mistake over on this left-hand side. I'm telling you, the right-hand side is probably going to be the easiest because set n equal to 0, you plug in, you get order of operations, and it's plain and simple. The left side is more complicated. You need to be careful with your pre-algebra skills. You need to be careful with distributing, combining like terms, the negatives, all of that. Just be careful, and that's why just quickly checking by multiplication up here, x times x is x squared, x times 2 is 2x, allows us to know we're good at that point. All right, so let's try another one. Y equals x plus 1. This is set up pretty simple for substitution. Is I'll take the x plus 1 and I'll plug it in for y in the bottom equation. So I get x plus 1 equals x squared plus 4x plus 3. No distributing needed. No combining like terms needed. But I do notice I have to set it equal to 0 to factor. So I'm going to subtract the x, and I'm going to subtract the 1. So I have x squared plus 3x plus 2. So what was nice about this one is I did not have to distribute. I did not have to combine like terms, but you always have to set it equal to 0 to factor. So I have a factoring problem. So I'm going to set up my box. I'm going to put my x squared in the top left. I'm going to put my 2 on the bottom right. And I'm going to remember that the diagonal that is blank is going to multiply to give me the same diagonal, a 2. And so it's going to multiply to give me a 2. And they're going to add to give me this middle term of 3x. So these two add to give me 3x. So I want to know what multiplies a 2 but adds a 3. And I think that's 2 and 1. So I'm going to put a 2x here and a 1x here. And then I'm going to fill in the boxes on the outside, the dimensions. So to get x squared, it's x and x. X times what gives me 1x, and that'd be 1. X times what gives me 2x, and that'd be 2. And I would just check, does 1 times 2 give me 2? And it does. So I know my factor is good. So I'm going to write them down now. I have x plus 2 times x plus 1 equals 0. Now that's factored. Set each one equal to 0. X equals negative 2 and x equals negative 1. Those are two x values for points of intersection. You're going to have a negative 2 comma something y, and you're going to have a negative 1 comma something y. We don't know yet, but we know we have two solutions. And what we're going to do is we're going to plug them into either one, but man, I think y equals x plus 1 is easier to plug into. So I plug in negative 2 for x. So y equals negative 2 plus 1, which really means y equals negative 1. So there is my first point of intersection. An x of negative 2 gave me an output of negative 1 for the y. So now I'm going to plug in negative 1 for x. So y equals negative 1 plus 1, y equals 0. So when I have an input of negative 1, my output is 0. So there's the other point of intersection. And if you look at all of the problems that we've done so far, all three, has my organization changed? And remember, that's the key. When it comes to math, is a lot of you need to work on just how do you organize your skills? How do you organize your work so you can understand what's going on? And to me, this allows me to see each portion of the steps in different parts. I substitute on the left-hand side, and I set equal to 0. I do all the busy work over here, and that allows me to factor. And then all my stuff over here is, look at this, it's the same organization every time. It makes it easier to remember where I'm at. In this third example, do be aware I have corrections on mine. Otherwise, it would not be a factorable quadratic. It would turn into a no solution, which is more complicated. I want to work on our factoring skills. And so make sure you change your numbers to be a 5, so negative x plus y equals 5, and a 13, x squared plus y squared equals 13. Now, just like one of the previous examples, we see there is no y equals. But I notice it's this top equation that has a y by itself. So I'm going to set this top equation to be y equals. So to isolate that y, I'm going to add x to both sides. And so I know y equals x plus 5. I'm going to take this expression, x plus 5, and I'm going to plug it in for the y in this bottom equation. And that's going to allow me to solve and find the points of intersection. Now, what's different about this bottom equation is that we have a y squared. All other times, we just had a coefficient, and it was easy. You distribute. So let's see what happens when I have a y squared. So I have x squared, plus y squared, but instead of y, I'm going to write down x plus 5, and that equals 13. You have to keep in mind that when you are dealing with squaring a binomial, you cannot distribute the exponent across the plus sign. It doesn't mean properties of exponents. What it means is you're multiplying a binomial, x plus 5, by itself, x plus 5. And we can get the product of it. X and x is x squared. X and 5 is 5x. X and 5 is 5x. 5 and 5 is 25. And so when I square it, I get x squared, and I get a plus 10x plus 25. And that's all from just squaring the binomial. I still have the x squared and the plus to drop down, and I still have the 13 to drop down. So this one was unique because it's squaring a binomial. On it, we're still going to combine like terms. So 2x squared plus 10x. Now at this point, you could start looking at realizing if I'm going to combine like terms, I'm also going to set it equal to 0. So I know this right side has to be equal to 0. So if you want, you can do it in one step of combining like terms and setting equal to 0. And I get plus 12. Now I could do my factoring here, but I notice all my numbers, 2x squared, 10x, 12, they are all divisible. That was a unique word, divisible by 2. And we have x squared plus 5x plus 6 equals 0. And that's going to make it a lot easier for me to factor. I'm working hard to try and follow my normal organization technique, but I believe I'm running out of room. So I'm going to set the factor box up right over here. We know x squared goes in the top left. We know 6 goes in the bottom right. We also can remember from the examples that 5x is going to be the sum of that diagonal. So I want two numbers, they add to 5. The product of this diagonal is the same as the other diagonal, 6x squared. So I want two numbers that multiply to 6, but they add to 5. And something tells me that's a 3 and a 2. So I get a 3x and a 2x. So now let's finish the factoring. To get x squared, I get x and x. X times something gives me 2x, and that'd be a 2. X times something gives me 3x, that'd be a 3. And I just verify, does the bottom right multiply out? 2 times 3 is 6. So I had the factoring. And again, I'm telling you, it's that left side that is the most complicated. It's where you distribute, where you combine like terms, it's where all the algebra skills come into play. It's more likely you're going to make a mistake over here. So doing the 5-second check of your factoring to make sure it works is going to help save you. Taking your time on this left-hand side is going to help save you because the right-hand side is really simple because it's already factored. So if you set x plus 3 equal to 0, you get negative 3. So you know negative 3 is an x coordinate of a point of intersection. Set x plus 2 equal to 0, you get x equals negative 2. So I know negative 2 is an x coordinate of a point of intersection. And then I plug in my y's. Y equals x plus 5. So y equals negative 3 plus 5. Y equals 2. Plug in negative 2. Y equals negative 2 plus 5. Y equals 3. And there are my 2 points of intersection. And again, take a moment and look at how the work is organized. It's the same every time. The left-hand side is where I do my substitution, my distributing, combine like terms, the factoring. Right-hand side, I have plugging in and getting the coordinates. With really substitution, just hardcore, it's a lot more complicated. And we'll spend another day on this to make sure we're good with some more problems. But the process is the same every time. Substitute, distribute, combine like terms, factor, set equal to 0, and solve.